Yes, 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 yes. Okay, again I'm starting. Yesterday it was your chance to ask me few questions. Today it's my chance to ask you questions. Okay, get ready, prove yourself. All the best. So, why does bulb glow in a circuit? It shows the circuit is complete. Are I am asking about bulb, not about circuit. Filament is broken. Filament is broken. Again and again, same answer. Jashwant, I've seen. High resistance because it has electricity. Wow. Because the bulb needs electricity. Bulbs need electricity. Okay, but why, if bulb electricity is there but bulb is not glowing, then what is the reason behind bulb is not glowing? Tell me the answer. Yes, 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 very correct. Advait, nice. See, see, we studied yesterday. There is a filament in a bulb. Okay, when this filament gets heat up, when this filament gets heat up, it produces light. This is the reason why bulb glows. This is the reason why bulb glows. Filament gets heat up, that is heating effect is there. Which effect? Heating effect. And this heating effect is responsible why our bulb glows. Okay? Or the filament is broken. If filament is broken, your bulb will not glow. There will be no light from your bulb. Not heating energy. Heating energy is different. Since the filament gets heat up due to the electricity produced, and then there is a light from this filament which can be visible to our naked eyes. Okay? Second question. I want answers from all of you. Which material can behave as both conductor and insulator? Material can behave both. Ma'am, you are not getting to pronounce the words properly. Okay, what is the problem in my pronunciation? Anandita. Okay, second question. Which material can behave as both conductor and insulator? Glass, water, plastic? No, which can behave both as a conductor and insulator. At one moment it is behaving as a conductor, but at the other moment it is behaving as an insulator. Semiconductors, electric cells, glass, water. Okay, I'll provide you the options. I'll provide you the options. Wait. First option, plastic. Second, copper. Third, human body. Fourth, wood. Now tell me which is the correct answer. Copper, copper, human body, copper, 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 human body, human body. Correct. Human body is the correct answer. Human body behave both as a conductor and insulator. Can you give me the reason why? Why cardboard? Human body, all of you who has said human body, the answer is correct. Can you give me the reason? I don't know, Riddhi. I don't want multiple answers from you, Jashwant. You can type once. It's okay, I can see. Human body, why? Why? Electrons? Electrons, sometime it has sweat, sometime it has joy. Correct. Okay. See, dry human body behave as a conductor or insulator? As an insulator. But see, dry body also if we touch and put our fingers inside, we will get a shock. So normally it is behaving as a insulator, but when it is wet, when there is a sweat, or when we are directly touching, electrons moves from our body to the ground, and that is the reason we get shock. Okay, that is the reason we get shock. So human body behaves both as a conductor and insulator depending whether it's wet or dry. Okay, any doubt? Because human body sometimes wet hand can get shock. Something getting it? Just one. What is this question? Okay. Next question. A bulb does not glow even in a closed circuit. Can you give me the reason why bulb does not glow even in a closed circuit? It is a quiz. Tell me, no cell. Array, it is a closed circuit. No cell can be a reason, okay? Broken filament can be a reason. Because if there are insulators, that can be a reason, correct? Maybe cell is not working, correct? Bulb might be damaged, yes. So for this question, according to the, if it is an MC, see, listen to me, okay? Wait, listen to me. There can be multiple answers, okay? Bulb is broken, wire is broken, if there is no cell, if cell is not working, so multiple answers. So if this question is in our MCQ form, you have to pick the correct answer. Three options will be bilkul incorrect and one will be the best that can be that will explain this question properly, okay? So next question. Next question. Why are wires covered with plastic? Yesterday I have explained this. Tell me the answer. Why are wires covered with plastic? Wires covered with the plastic. So we don't, why you're touching wire? Plastic is an insulator. Yes. Safer and acts as an insulator. Very good. It prevents us from getting shock. It's covered as it is an insulator. Very nice. See, there is a copper wire inside that plastic covering, and that cover is protecting that copper wire to directly come in touch with the atmosphere, directly come in touch with us. Okay, if we will like touch that copper wire with our hands, we will get shocked because our body works as a conductor also. Okay, entire current will flow from a body and our body will get shocked. So please don't try this at your home. It is very dangerous. Okay, so that plastic covering protects that copper wire, protect us from touching that copper wire because that plastic is what? Plastic is what? Insulator. Okay. Insulator. Okay. Any doubt till now? Little hard questions? You want little hard questions? Okay, I'll ask little hard questions, okay. Which increases current flow? Which increases current flow? What is the reason behind increase in current flow? I will give you the options. Reason behind increased current flow. I'll give you the options. You have to pick the correct answer, okay? Four cells. Option two, option two. Can you repeat again, ma'am? What is the reason behind the increased current in a circuit? Okay, this is the question. What is the reason behind the increase current, or which option increases the current flow in a circuit? Option 2, option 2, option 2, option 2. Reason, reason, reason. I want reason. Fast, guys, fast. Reason. More cell. More cell will create what? Give out more energy. Okay. More cells. Ma'am, sometimes more cell also the bulb might not have good current sometimes. Why? More cells also the bulb. Why? More cells, more current. More cells meaning more electrical energy. Motion cells, more energy. Yes. See, more cells, more electrons, more current. Okay? One cell, few electrons. Two cells, more electrons. Three cells, more and more electrons. More electrons will flow, more current will flow in the opposite direction. So, more cells gives more current. Okay, very good. Next question. Next question. Very basic question. Electric current flows from which direction to which direction? From which terminal to which terminal? Wait. I got a question from Bipro. Ma'am, I forgot one is electron and human body. What is there? What is there in a human body? Positive to negative, positive to negative, positive. And electrons flows from which direction? Electrons flow from which direction? Electrons flows from which direction? From battery to bulb. Wow, Yenam. Electrons flows from which direction? Electrons also from plus to minus, negative to positive, negative to what? And all the people, all of you who are saying negative to positive, electron flows from negative to positive only. And whoever is saying plus to minus, you are wrong. Clap for yourself, you are wrong. Plus to minus is wrong, negative to positive. Electrons always flow from negative terminal to positive terminal, and current flows from positive terminal to negative terminal. This is negative, this is positive. So electrons are flowing from negative to positive, while current is flowing from positive to negative. This is the reason why electricity is there, okay? Electrons are negatively charged particles. Okay. See, I'll give you two options. You have to tell me, two statements. You have to tell me which is the correct statement. Okay. And is the second statement is the correct reason for first statement. Okay. So I'll give you two statements. You have to tell me. Yes, current is nothing but passing of electrons only. That is the reason current is there. Okay. Next question. First option, current flows in closed circuit. This is the statement one. Reason. Is this reason is also correct, or is this a correct reason for this? Okay. Very easy. You can write these questions or take a screenshot also. Ah, see, I have given you two statements. Statement one says current flows in a closed circuit, and statement two says path is complete. So you have to tell me, are these two statements correct? Which statement is true, which is false? And second thing, is this second statement is the reason for first statement? Is the reason for first statement? Reason for first statement. Both statements are right. Both statements are right. Both statements are right. Correct. Is this the reason? Is this the reason? R is the correct explanation. R is the correct explanation. Correct. See, current always flows in a closed circuit. Current always flows in a closed circuit. If the circuit is not closed, switch is open, wire is broken, okay, in that case, current will not flow. Current will not flow. So, a closed circuit is called a complete path. Closed circuit is called a complete path. So, this reason is a correct explanation for this statement. So, both your statements are correct and this reason is a correct explanation for this statement. Okay? Nice. If Jaswant wants to ask one question, if current gets used up in the bulb, how does it still remain the same in the series circuit? If not, you are not changing the bulb, if you are not changing the cell, see, current is not getting used up in bulb. There is a heat loss, okay, there is a heat loss, but some amount of current again goes back to the cell and again it is moving until and unless every electron gets dissipated. If a circuit, if the cell, all electrons are dissipated or removed or moved or wasted, then your bulb will not glow in that case, okay. But that is how your cell is used up. And this cell is used up because there is some heat loss in the bulb. And that heat loss will result in your cell dissipation. Clear, Jaswant? Yes, please ask doubt. Your doubts are welcome. Veldruti, please ask me your doubt. Anuj sir is busy with something else. If Anuj sir is busy, you don't like me? Am I not teaching good? Please bear me for more days, please. How are secondary cells working? Secondary cells are working same like primary cells, but we can charge them again and again using fuel or some other materials. Okay? Oh, thank you, Jaswant. There was one doubt. One doubt. Please ask me. Thank you so much. Thank you so much, guys. Ma'am, can we use any insulator except plastic? See, wood is insulator, your plastic is insulator, your objects at your home like made up of wood or plastic or so many things are insulators. Only metal is a conductor, human body is a conductor. See, this one question, very important question. From this option, choose which is conductor, okay? Which is conductor? Distilled water, salt water, okay? Mm, water containing powder, talcum powder, or simple tap water. Which is the conductor? Which is the conductor? I want one minute. You told yesterday electron negative to positive and positive to negative. I forgot the name, ma'am. Bipro, see, electrons always flows from negative to positive because electrons are negative, so they are at the negative end. Who will attract electron? A positive end. So one who is attracting, they will go to them. Obvious, they are negative, so they are at the negative end and they will be attracted to the positive end. So electrons are moving from negative to positive and opposite to that electron current is flowing. So current is flowing from positive to negative, okay, and electrons are flowing from negative to positive. Wipro, any doubt? Option 1, option 1 wrong. You guys are wrong. Option 4 wrong. Salt water is a conductor. Salt water is a conductor. Reason. Oh, I told salt water is a conductor. Tell me reason. Reason. Option 3 is wrong. Option 3 is wrong. Option 1 is wrong. Option 4 is wrong. Tell me why salt water is a conductor. Because salt has electrons. What is salt? In chemistry, you might have read salt. What is salt? NaCl. So Na and Cl are ions, and ions contain electrons, right? So salt water has ions which further has electrons which conduct electricity because it has many ions. Very nice. Any doubt till now? Any doubt? Just one. Please don't type so much. Balla, please don't type so much. Okay. Ma'am, because salt is ion and electrons, ma'am. Very good. NaCl. NaCl is what salt is. Na plus Cl. So Na is ion, Ca is ion. Ions has electrons. If there is electrons, there is a it behaves as a conductor. Simple. Next question. Next question. So next question. First, more cells, more cells increases brightness. More cells increases brightness. Okay. More cells increases brightness. Reason is more energy supplied. Already discussed. I want to know the answers. I want to know the answer. More energy supplied. More energy supplied. I don't know if I will teach you offline also, but whoever will teach you, please try to put your doubts in front, okay? If you will ask, he will be or she will be excited to answer. But don't ask rubbish question, only doubts from the chapter. So that the teachers get excited by your doubts only, right? So excite them by asking reasonable doubts, not unnecessary doubts. Option A, both are correct. There is no option, guys. There is no option. You have to tell me both are correct. And is this reason a correct explanation? This reason a correct explanation? See, I'll tell you the answer. I'll tell you the answer. Wait. 2 more seconds. 2 more seconds. 2 more seconds for giving a correct answer. 2 more seconds. See, more cells, more electrons. More electrons. More electrons. More electrons. Bulb will be brightest. Okay. But what if we make a circuit in series? Then what will happen to your bulb? And we have applied one more bulb here. What will happen to this? Which bulb will glow? More. Dimmer, nothing. Bulb will become dimmer. I have a news for you. I have a news for you. Guys, I'll be teaching you for 2 hours. Okay? This class and the second class. Now tell me, am I the best teacher? No? No, you can't see electricity. No, you can't. Thank you so much. I'll be taking your second class because you're very nice. Oh, wow. Okay. Okay, thank you. Thank you so much. Thank you so much. See, in this case, electrons will move from here or here? Here. So, current will flow from here. Current will flow from here, positive end. So, both the current will first reach here. Both current will reach here. So, this will be the brighter one. There will be some heat loss. Then current will go to the second terminal and one will go here. So, this will be the dimmer one. This will be the dimmer one and this will be the brighter one. Okay. Bulb 1 will be the brighter one and bulb 2 will be the dimmer one. Any doubt in this? Ma'am, sometimes your voice is breaking. Now it's correct. Am I audible? Am I audible? Am I audible? Yes, 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 yes. Yes. Okay. See. Any doubt in this? Which bulb is brighter and which is dimmer? From my side, my mic is working fine. If there is some connectivity issue from your side, please turn off your net and then connect it again. Try to correct your network. Because of network might be this issue. My mic is working fine. Yes, I can see all of your messages. Maximum current is passing through bulb 1. So your bulb 1 will be the brighter one and your bulb 2 will be the dimmer one. Okay? Didn't understand? Yes, Ankula asked me a doubt. Again, I will explain this. Again, I will explain this. See, there is one cell. Again, I am explaining. There is another cell. Okay? And one bulb is here and the second bulb is here. Now, very important, huh? Try to understand this. If you have doubt again, please ask me, I'll explain you again. Current always flows from positive terminal. Current 1, current 2. This current will come here, this current will come here. Both the currents I1 plus I2 will pass through bulb 1. Okay. So more current, this bulb will be the brighter one. Okay. More current. So this will be the brighter one. Some heat might loss, only a little because there is no resistance. There is no resistance. If we will connect a resistance, na, the heat dissipation will be more. So that part is for the later classes, okay? But from this bulb will be a little, this current I1 and I2 will come again here. I2 will go here and I1 will go to the negative terminal. So only I2 is here. Less current, so it will be the dimmer one. Dimmer 1. So bulb 1 is brighter and bulb 2 which is less current. I2 small than I1 plus I2, right? No one left because of your doubt. You are 8th grade students. No. Okay. Any doubt? Important, very important for your concepts. Any doubt? Understood? Nahi. Okay. Time up. Okay. No, there's time. Time is left. Okay. Now, one last question. One last question from my side to you. Why circuit diagram use symbols? Why circuit diagram use symbols? I'll start the light chapter then. A small revision of light chapter, okay? Then we'll go with the light chapter questions. Okay. Because it is easier to draw, easy to understand, to explain the components so that it can be easy to understand. If you want to draw this is a nice question. You can draw or take a screenshot, okay? But who does not? Please tell me the answer for why circuit diagram uses symbols. Correct. It is easy to represent and it is the standard way to represent. Okay. Easy to understand and standard way to represent. First thing, if you will draw proper bulb, like proper filament wire, the metal bulb, and then this resistance proper diagram, wire proper diagram, can you like it? It would be easy for you to understand. We can't draw real objects, right? Very nice. Anandita, very nice. We can't draw real objects. So, we have a standard symbol for each and every component so that we can draw a small circuit to cover that topic. So, this standard and easy way of representation is very essential. That is the reason we draw symbols for our components. Okay? Symbols for our components. Any doubt? I have a doubt. Aradhya, please ask. Please ask, Aradhya. Aradhya, can't see your doubt. Aradhya, what is your doubt? Your doubt? Ask me your doubts. Which branch? Electrical engineer. B.Tech and M.Tech. Okay. When human body, when human body is wet, it is, it is, it behaves as a conductor. Wet human body behaves as a conductor. Okay. Thinking for a future by very good. Okay. See, now I will start the recap, like revision for light chapter. Then we'll again do the quiz for light chapter. Okay. So I'm starting with the revision. Light. In light, what you have already covered is the basics of light, medium of light, rectilinear propagation of light, and shadows. I'll not explain you the complete topic. We'll just have a small recap of this chapter, like we had yesterday for the electricity chapter. So it is a revision, okay? It is a revision. See, what is light? Light is a electromagnetic energy. Electromagnetic means electrical plus magnetic energy ka combination is what light is. And what light do? It creates a sensation of vision. Light help us to see objects, to see your chat, okay? For you people to see me. So light is helping us with everything through which we can see. So light is a combination of two waves, electrical waves and magnetic wave. Combined together, we say electromagnetic energy wave. Okay. So light, there are two sources of light. Okay, two sources: luminous sources and non-luminous sources. What are luminous sources? Luminous sources have their own light. Luminous sources have their own light. Okay. What are you saying? Ma'am, our topic is so we can have fun class tomorrow. Please, ma'am. We are having fun only. We are having a little discussion or recap or revision for your before your test. So it will help you. Please try to cooperate. It is for you only. Okay. See, two sources, luminous sources, non-luminous sources. Luminous sources are the sources which have their own light, which emit their own light. Okay? And non-luminous sources are the sources which becomes visible due to luminous sources. For example, sun. Sun has its own light. So sun is a luminous source. But moon reflects the light of sun. So moon is your non-luminous source. Okay? I'm sorry. Okay. So clear, clear. What is wood? Wood is a luminous source or non-luminous source? Luminous, 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 non-luminous. Why non-luminous? And why luminous? Reason. Acha, luminous also and non-luminous also. Why? Can you please tell me the reason? Wood is a non-luminous source. Wood does not have its own light. It reflects light from non-luminous objects. Do we get light from wood? No, na. A is wrong. Wood is a non-luminous source. They can might see. Wood is a non-luminous source. Okay. Next. Now, mediums of light. There are basically three mediums for light to travel. First is transparent medium. Second is translucent medium. Not seen. Ah, Gautam, I saw your chat. Ask me what you want to say, Gautam. Yes, I am able to see your chat, but right now I'm explaining now. So I'm seeing in front. So at that moment I can't see your chat. So first let me explain that topic. Take a revision of that topic. Then I'll ask you if you have any doubt. So if you are typing when I'm explaining, I can't see your chat. Okay. So wait for 3 minutes. Okay. It will hardly take more or less than 3 minutes. Now there are three types of medium. First, transparent medium. I'm looking at you guys. So no chat. Wait for 2-3 minutes. Okay. Can you show previous slide? Yes, I'll show you previous slide. This is a previous slide. Now let me explain. Okay. Now there are three types of sources. Transparent, three types of medium. Transparent medium, translucent medium, and opaque medium. Opaque medium. Transparent medium which allows light to pass from it. Okay, it is allowing the complete light to pass from it. Can you give me the example for transparent medium? Now I am seeing your chat. Clear water, glass, window. Hi Sai Pranav, I can see your chat right now. Type if you want to say anything. Glass. No, plastic is not transparent, okay? Plastic is not transparent, Mahan. Clear water, air. Plastic is translucent. No, plastic is opaque. I can see your chat right now. Type whatever you want to type. Then I will explain translucent medium. Glass, butter paper, glass. Butter paper is translucent. It does not allow. See, there are three medium: transparent, translucent, and opaque. Transparent medium allows light to pass from it completely. If there are three rays of light, okay, and there is a transparent medium, all these three rays will pass through it. Okay, it is not stopping any ray. So this is transparent medium. Second is translucent medium. Translucent medium stops some of the rays and some rays passes through it. Okay, it stops some of the light and some light it allows to pass. So this is your translucent medium. It has stopped one ray and it is allowing two rays to pass through it. Then it is translucent medium. And third is opaque, which does not allow light to pass through it. That medium is known as opaque medium. That medium is known as opaque medium. So when complete light is passing through a medium, transparent medium, some light is passing through a medium, translucent medium, and no light is passing through a medium, then it is a opaque medium. So clear, clear. Any doubt? Any doubt? How is plastic opaque? See, plastic is not allowing light to pass from it. Keep a plastic, pass, like turn on your torch or something and see if you can see your torch light from behind the plastic. No. Plastic is opaque. It is not allowing light to pass through it. Okay. For example, the chair which you have near you, or the plastic chair or a plastic box. Okay, bring your mobile light near to your plastic and see if that light is coming from the back side of your plastic. No, it will not come uh, at the back side of that plastic. Okay, plastic bottles. Plastic bottle is something different. Plastic can be anything. Plastic bottle is a transparent bottle, la Bisleri bottle you are saying, na? So that allows light, but only some light. So that is a translucent medium. Okay. Wait. Sai, ma'am, I'm not able to understand the last topic. Please explain. Which last topic? Mediums or sources of medium? Sources of light. Plastic cover, mobile cover, see, plastic mobile covers, plastic polythene, everything is different. These plastic chairs, so whatever that thing is, according to that thing, you can examine whether it is a transparent, translucent, or opaque. Okay? Ask me your doubts. Still, we have time, Avyog. Ask me your doubts. Doubt in luminous and non-luminous. Doubt in medium. Periscope we will ultimately teach periscope, but before that we'll start starting of this chapter. No. Okay. So done with the medium. Opaque done. Rectilinear propagation. Rectilinear propagation is light always travel in a straight line. Light always see. We are having a summer camp, okay, in our schools. So these activities we are going to perform it practically. Practically, no books, nothing, no theory. We will see how light is traveling in a straight line, how reflection is done using some practical appliances. Okay. So if you guys are interested, you can come to our summer camps and we will show you how these things can be done practically. Okay. Light always travels in a straight line. Medium. I have got a doubt. I have a medium doubt. Please ask. Yes, there will be a test quiz. Whatever is there, you should be ready for that. Okay. Now the revision classes are going on. So you should be ready with anything that is coming. Either it is a quiz, either it is a test. You guys should be ready. Okay. Ma'am, a paper with less thickness allows light. So that is a translucent medium. Okay. Translucent medium. Paper, no issue. Okay, then ask me a doubt. Yes, there will be games also. See, okay, so light always travels in a straight line. This we have done an activity also. There is an activity in your books also. So what will be that activity? You'll take three cardboards. Okay, one cardboard whole, second cardboard whole. I know you are aware of this activity, but this activity is a proof, and there is a candle. Okay, candle, and from here I can see. If I am able to see this candle, Then only then I can be able to see this candle when these are connected in a straight line. But what if this circle, this hollow is not here and it is here somewhat, this hollow is not here and it is somewhat here. Can you see this light? Can you see this light? Can you see the light from the candle? No. No, no, no. Can you tell me the reason why this candle is not pinhole camera? Yes, correct. Why this is not visible? It was in your sixth grade. That is the experiment we generally do for rectilinear propagation of light. Okay. And one experiment you can do at your homes. Take a torch, okay, or take a laser light. Take a laser light, okay. Darken your room, start your laser light and spread some talcum powder on it. So you can easily see the rays coming from your laser. Okay, you can see the path. You can trace that path because that particles will help to see that path. So please try that. That is safe and you can try it at your home, but no pressure. Okay, please answer. Ishita, what you want me to answer? Tell me. Light travels. I have a doubt. Ask me the doubt. Ask me the doubt. Ask me the doubt. Yes, I can see. Does light stay inside forever if you open it in a year later? Does it still shine out? Light from what source? See, sun is there forever. So sun is there, but like if you want light from bulb or tube light, it gets exhausted after some days or some months or some year. The cell will discharge. So it depends upon the source. Okay, it depends. Time. Still we have time. Still we have time. Time up. Second class is also mine. Please wait. Ma'am, doubt. Ask me the doubt. Ask the doubt. Don't write my doubt. What doubt you have? Ask. Ma'am, will we have a summer camp? If you want to get enrolled, then you can have the summer camp. Light can go in a straight line, but if we keep turning point, can we see it? The light, see, light travels in a straight line. Light is coming from that source. It is coming straight to a point. But if you like, if you you will turn this tube light to this area, this tube light is an extended source. So light are not traveling parallelly. It is paralleling in every direction. It is moving in every direction, but in a straight direction. But if we have a small source like a laser, see, like a laser, it is coming straight. If I'll point this laser in this, it will go in this direction. It will not come in this. So using a point source light, we can see the direction. Okay, we can see the direction. Yeah, I'll explain you all the topics, okay? Now your time is up. I'll meet you after 10 minutes. Okay? Bring your doubts and then we will discuss your doubts also. Please ask doubt. Okay? After 10 minutes we will meet. Okay, bye. Okay. So light always travels in a straight line. I'm starting a small revision again. Light always travels in a straight line. See, this pinhole camera was the experiment we did in the previous classes for seeing this light always travel in a straight line with the speed of 3 into 10 raised to power 8 meter per second. With the speed of 3 into 10 raised to power 8 per 10 raised to power 8 meter per second. And what is the examples? See, light coming from a tube light, light coming from the car headlights, okay. Light, what are the examples here? From the scooter. Close your eyes, you can see the bulb? No. See, if you almost close our eyes and try to look towards a lighted bulb, it appears to give us light in the form of a straight line. In a dark room, there is a window, okay. A dark room, there is a window. Do we have basketball? I don't know about the basketball, guys. Velocity and speed are different things. Velocity is not known as speed. Velocity is different from speed, but somehow similar to speed. But there is only one difference which we will read in motion chapter, okay? See, in a dark room, there is a window, okay? And sun rays are coming. At that, you can see that light is traveling in a straight line in that case. At your home also, you have seen light coming from small hole or something in a dark room. It travels in a straight line, okay? Next is, there is a straight pipe. Through straight pipe, you can see this candle. But if you're bending this pipe, you can't see this candle because light always travels straight. But in this case, light will travel straight and then it is bended. Light does not change its path. It travels straight only. Okay? So, in this case, light is not visible, it is not reaching our hand, but in this case, it is reaching our eye. So this experiment explains us that light travels in a straight line. There is on that straight line is known as rectilinear propagation of light. Light has no mass and momentum. What you are asking, Gautam? This is out of the syllabus. Shadows. Shadows. For shadows, three things are necessary: source of light, an opaque object, and a screen to obtain that shadow. Okay, three things. What are those three things? First, source of light. Source of light. Second, opaque object. Opaque means which does not allow light to pass through it. Opaque object. And third, screen to obtain shadow. Okay, obtain shadow. Now there is an opaque object, for example, this wall, and there is a source of light, for example, this candle. Okay, this candle will emit light. This candle will emit light. Will emit light. Light is going. Will this opaque object will pass this light to the other phase? This opaque object will not pass these light rays to pass through it. So only this light here will reach, but this area there will be no light, so this will be a shadow of this object. So this will be a shadow. Okay, the screen where we can obtain the shadow is known as screen to obtain that shadow. Okay, so here there is no light, this is restricting this light, so no light has been reached here in this portion, so a dark side will appear, and that dark side on the screen appears as a shadow. Okay, any doubt? Any doubt? Very important. A simple brief. No, no. Any doubt? I'll ask you questions. Okay, I'll ask you questions. So ask me doubts. Since this question is not allowed. Okay, ma'am. Can I ask you then a question on shadows? Yes. Okay. Very nice. Okay. One question. See, there is a point source. This point source shadow I obtained is here. Now I have an extended source. Extended source means uh, multiple points connected to each other which create a bigger object. Okay, extended object. I have a bigger object. Now what happened? What will happen to a shadow? What will happen to a shadow? What will happen to a shadow in case of an extended object? Anandita, focus on the shadows, not on my dress. Smaller, it will get dark. It didn't, and I didn't understood. Bigger, shadow, it will be short. A shadow will be small. It will not form a shadow. Bigger. It will be how? Shadow will get smaller. Why shadow will get smaller? Why shadow will be smaller? Shadow becomes bigger. See, I'll explain you. I'll explain you. See here. There is an object. This is a screen and this is a source of light. Okay. This is a source of light. Light is passing to this area. Okay. But not in this area. Light is not passing here. Okay. This area. There is no light. So there will be a shadow. A dark shadow. In case of small objects. Dark shadow. Okay. Now there is an extended object. Extended object. Extended object, opaque object, extended source. Extended source. First thing, light can pass like this also. Clear, light can pass like this also. Second, light can pass like this also. Okay, light can pass this like this also. So this area is where we will obtain a shadow. Shadow. But what about this area? This area and this area? This area and this area? We will obtain a light shadow. Light shadow means a small, a light, not that dark, but a lighter shade. Not that dark. This is a very dark shadow. Okay, but this is lightly, little darker. Okay, little and little darker. So in case of So in case of extended source, a dark shadow and a lighter shadow. You can see this like in a real life also. When we are standing, we see a shadow. But near a shadow, we see some light shadow. This light shadow occurs in a extended source, a bigger source. Okay? Shadow is in third, a dimmer one. We see a point of shadow where object is extended. Umbra and penumbra. So in case of extended, penumbra is there. Don't go to umbra and penumbra, only a lighter and darker side. Okay. So one more question I have for you. Are you guys ready? Any doubt? Any doubt? Any doubt? Ask me, ask me. I am seeing your chat. Ask me. First I was explaining. Yes, Manila, ask me. Ask me, ask me. I was making you explain, so I was not seeing your chat. Now ask me. Ask me. Ask me. Ask me the doubt. What is A? Ask me the doubt. Please, guys, ask me the doubt. Ma'am, I have a doubt, but what doubt? I can't see your doubt. Ma'am, what is the outline of shadow? Outline of shadow means? Ma'am, can I ask you ask me questions? Okay, I got up, ma'am, rectilinear propagation once again, ma'am. So, Diksha, rectilinear propagation is just very like when light travels in a straight line, na? Matlab straight line, not here, not there, only a straight line. That is known as rectilinear propagation. Okay, rectilinear propagation is Simply that light travels in a straight line from a source to an object. That is the reason when we are bending a tube and we are trying to see candle through a bended tube, we can't see that candle because light is not reaching our eye. It should be straight into our eye. But when there is a bend, light can't travel in a bent form, na? So in that case, light is not coming to our eye and we can't see candle because light always travel in a straight line, and that is known as rectilinear propagation of light. On 25th, you have your test. Veldruti, ask me a question. You are not even clearing my doubt, ma'am. Ask me a question, bacha. Ma'am, will the shadow be the exact as an object? Number of times shadows is same as an object, but depends upon the position also. We'll learn it no this class only. Okay. Colorful shadows, no. Shadows are always dark. Ask me question. Trishika, can you please answer my question? What is your question, beta? Vaishnavi, what is wrong? Speed of light is always 3 into 10 raised to power 8. Vilruti, ma'am, why do you call? Beta, electricity we are not reading right now, na? But still, why do few bulbs get dimmer and start blinking as the switch is on? Why does this happen? Because current is not reaching there properly, or the fuse gets melt, or the tungsten melts. In that case, shadow is always black because light is not reaching there. Things we can see colored are because of light only. So, opaque object restricts all the light. There is no light, so there will be a dark only. It depends on source of light, opaque object. Okay. Now, ma'am, answer my question. Sehes, what is your question? What is your question? What is your question? No, we can't obtain colorful shadow. Okay, I have a question for you now. I have a question for you. I have a question. Which object will not form any shadow? Which object I will only see at night? You give me answer for this. Which object will form no shadow? Glass, wood, your metal, and fourth stone. Which will not form a shadow? Glass. Glass, 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 glass. Why? 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 Transparent, transparent. Okay, very nice. Second, a shadow becomes bigger when becomes bigger when object move closer to screen, object moves closer to light source, light intensify increases, object become transparent. 2. Object moves closer to source. When object moves closer to the source, when object moves closer to the source, the darker side is now bigger. Okay, your shadow has now increased. Okay, whenever, see, very important. See, this is your source. First, your object was here. So, There, this is your shadow in this case. Now, your object is here. Object is, this is your object, okay? Same size. Now, you have a bigger shadow. You have a bigger shadow, okay? You want me to repeat the question? What is the condition for where shadow becomes bigger? Shadow becomes bigger. Shadow becomes bigger. Why shadow becomes, when shadow becomes bigger? I have explained this. Bigger object, no. Object size is same. Object size is same. Object size is same. Not bigger. I have a doubt. One day after. Akshara, shadow of a bottle will be on a surface where your bottle is kept, not in a bottle. Object move closer to the light source. When object move closer to the light source, this object was here, now it is here. So rays are diverge more. Now your shadow will be bigger. Okay. So next thing, very important. This we have studied, there should be a source, there should be an opaque object and there should be a screen for which we can obtain our shadow. The shape, size and other characteristics of shadow depend on position and distance. More nearer or farther, size of shadow depends on that. Distance between object and surface, yes, it depends upon the distance between object and the surface also. And the size of source. Point size and extended source. We have seen penumbra and umbra. Okay. 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 Penumbra and umbra, you don't have to read it now. The dark shadow and the lighter shadow. Lighter shadow, okay? There was a question. Shadow sticks. Okay, you want to study shadow sticks? See, shadow stick is what? It is a vertical pole that is placed in the ground. Okay, that is placed in the ground. Now, sunlight will cast the shadow of this stick on the ground. Sunlight, sun will cast the shadow of this stick on the ground. Okay. Sun moves from A to C. A to C. Sun is moving from A to C. The length of a shadow will change. The length of a shadow will change. Okay. The length and the position of shadow depends on both time of year and time of day. So at noon, that is 12 in the noon, shadow is different, and in morning and evening shadow is different. So position of sun is defining the shadow of this stick. Okay. And like at noon that is at 12 in the noon, this shadow is shortest. This shadow is shortest. While in morning and evening, we have a bigger shadows. We have a bigger shadows. Okay, a larger shadow. However, shadow sticks are not good clocks. The azimuth of the sun's shadow at the given time changes throughout the year with the sun's declination. So, with time, a shadow is changing. Okay, depends upon year, length of a year and length of a day. Any doubt? Any doubt? Sai? Sai, any doubt? Shadow stick, I explained. No. Okay. Now, next topic. Worksheets already done. So, we are not covering worksheet. Just the basic revision of all the topics. Now, reflection. See, there is a mirror. There is a mirror. Okay? This is your mirror. When a light strikes the mirror, when a light strikes the mirror, the light gets reflected. The light gets reflected. Reflected means it moves back to the same medium. Now, how it will move? We'll see here. It moves back in the same medium. So, it is moving back in the same medium. So, what are the conditions while it is moving back in the same medium? There are some angles. There are some angles. So, we'll draw perpendicular to this mirror. We'll draw perpendicular to this mirror. This perpendicular is known as normal. So what is normal? Normal is a perpendicular drawn to a mirror. Perpendicular means 90 degree. 90 degree. Any line drawn at 90 degree to the mirror is known as normal. The light which is incidenting the mirror is known as incident ray. Incident ray. Okay? And the light which is reflecting back to the same medium is known as reflected ray. Reflected ray. Angle between incident ray and normal. Angle between incident ray and normal is known as angle of incidence. Is known as angle of incidence. Okay. Angle between incident ray and normal. Angle between reflected ray and normal is known as angle of reflection. Angle of reflection. Till here, if you have any doubt, yes, Bipro Datta, ask me a doubt. The right-handed line is known as here. The glance of angle of reflection. I'm explaining glance of angle also. Till here, any doubt? Any doubt? Ask me a doubt. This is a doubt session. Only ask me your doubts. No, no, ma'am. Thank you, Anandita. Ask me, ask me, ask me. Okay. Again, this incident ray is also making some angle with this mirror. Is this making some angle? This angle. This is known as your glance angle of incidence. Glance angle of incidence. Angle between incident ray and mirror. Angle between incident ray and mirror is known as glance angle of incidence. And this is known as glance angle of reflection. Glance angle of reflection. I'll give you a question. Ask me doubts. So, an incident ray is there, a reflected ray is there, normal is there. Normal is what? 90 degree. Angle between incident ray and normal, incident angle. Angle between reflected ray and normal, reflected angle, angle of reflection. Angle between incident ray and mirror. This is mirror, right? This is mirror. Angle between mirror and incident ray, glance angle of incidence. Angle between reflected ray and mirror is known as glance angle of reflection. Now, with this, with this, there were two laws. There were two laws. First law of reflection says that incident ray, normal and reflection. What it says? Incident ray, normal and reflection all lie in the same plane. All lie in the same plane. That is incident ray, normal and reflection. They are on the same plane. Second law is saying that angle of incident, that is angle I, is equal to angle of reflection. Is equal to angle of reflection. Incident angle and reflected angle are always equal. And what about the point of incidence? See, this is your point of incidence. The point where your incident ray is striking is known as point of incidence. Kaleidoscope also we will, but in later class, okay? Before I didn't mention, sorry, I forgot. I thought a point of incidence is what you have studied. This is a revision class, na? So incident ray when strikes an angle at a mirror, it is incidenting at a point. This point is known as point of incidence. Okay. Sorry, my bad. Sorry. Next time I will keep it in mind. Okay. Okay. See, now I'm giving you one question. If your angle of incidence is 45 degree, find glance angle of reflection. Find glance angle of reflection. Tell me glance angle of reflection. हाँ, ask me your doubt, Gitika. Rasalai, 135 is wrong. Malela, your 90 degrees also wrong. 45 is the correct answer. See, this angle is your 45. So angle of reflection is also 45, correct? 45. This complete angle is 90 degrees. So 90 minus 45 will be 45. Glance angle of reflection. Glance angle of reflection. Any doubt? Any doubt? No. No. Okay, one more question. If your glance angle of incidence is 30 degree, glance angle of incidence is 30 degrees. Can you find me angle of reflection? I want angle R. Can you find me angle of reflection? See, objects are colorful, but shadow is black because it is not allowing light to come to it. Okay? Since there is no light, therefore it is dark. 60, 30, 505. Wow. Nihal, Nihal 50. 50, 50. Wrong. 50 is wrong. 70 is wrong. 30 is wrong. 60 is your correct answer. See, glance angle of incidence is this angle. What is your this angle? 30. This is complete 90. So this is your 60. And angle of reflection is what? Equal to angle of incidence. So this angle is also your 60 degree. 60 degree. Any doubt? Any doubt? Yes, ma'am. Bipro asked me. From the chapter, not from outside. Okay. Any doubt? Online or offline? I don't know, but beta. I don't know. Okay, ma'am. Ma'am, why human shadows change size? Why not object? See, object size you're not changing now. Object is kept there. You can change the size of object by pressing it or by pulling it, okay? But according to that, size of object changes. If your size of shadow changes, okay, if you're moving it near to the source, if you're moving it away from the source, shadow size changes. If it is a noon or morning or evening, shadow size changes, okay, but object is not changing. Okay. Next question. A ray strikes a mirror at 30. A ray strikes a mirror at 30. If Find angle between incident and reflected ray. Find angle between incident and reflected ray. Ray is striking at 30. Find angle between incident and reflected ray. I'm here only. I'll just give you, like, if you want to write it, you can write it. So I'm standing here only. I've given you a new question. Tell me the answer. 30 is wrong. 30 is wrong. Shadow dependent slide. I will. After like 15 minutes, I will put that slide. Okay. 120 is wrong. Mahita, ask me a doubt, beta. See, 60 is the correct answer. There is one, just one. Light is spreading in all directions, but it is moving straight. So, in which direction it is moving will show you where the object, what object is are placed at that direction. Okay. See, can I remove this? Can I remove this slide? Can I remove this? Okay. See, question was light get incident at 30 degree. Light is getting incident at 30 degree. So this is your 30 degree. What you want? Angle between incident ray and reflected ray. So this is reflected ray. So this angle is equal to this angle. So this is also 30. So angle between incident and reflected ray is 30 plus 30 equals to 60 degree. Okay. 60 degree. 60 degree. Next. We have covered these points. Normal angle of incidence, angle of reflection, done. Glance angle of incidence, glance angle of reflection, done. Laws of reflection, done. Mirror, object, image, real image, virtual image. Okay, this is important. What is mirror? You have studied what is mirror. Shanvika asked me a question. If light travels in a straight line, then why when we on the light, the whole room have light? Because this light is spreading in all direction. But can you see light like behind the objects? No. At corners there is a darker. Corners are darker. For example, behind the behind the wall, you can't see. But wherever this light is spreading, it is moving straight in all directions. So it is lighting up the whole room. But if there is a wall here, then behind that wall you can't see. Behind that wall you can't see because that wall is an opaque object. It is restricting light to this area only. So behind this you can't see there is a wall. Mirror is a highly polished surface which reflects light. Okay, very nice. Very nice, very nice. Nice. Very good. Mirror is what? Highly polished surface. See, there can be two surfaces. One is polished surface and one is not smooth surface. Smooth surface. Okay. One is not smooth surface. Okay. Smooth surface reflects light according to the laws of reflection. According to the laws of reflection. But uneven surface reflects light in all direction. Okay, lights are incidenting, but it can move away in any direction. Okay, it is moving, it is reflecting back in any direction. Okay, in case of uneven surface. So mirror is what? Highly polished surface, smooth surface, capable of reflecting good fraction of light from its surface. So it is reflecting all the light coming to it to the same uh, surface. Okay, same surface, same space. I'll ask you quiz also, but let's go through this once. Object is what? Which is giving out light. What is image? Image is like reproduction of object. Any object which can be obtained or not obtained on screen. Okay? Which same as an object. A reproduction of object or objects image is known as image. Okay, so these are two types of images: real image and virtual image. Real image are the image which can be obtained on screen, and virtual image cannot be obtained on screen. It is behind the mirror. Okay, so this is what mm, this is your plane mirror. This is your plane mirror. Okay, you have a object here. You have a object here. You have an object here. Okay, the light is going straight. It will pass straight. It will pass straight through a plane mirror. It will go straight to a plane mirror. Thus, it will go or not? No. Yes. Yes. Why light? Plane mirror reflects light. Plane mirror reflects light. It will reflect light in the same direction. But when we will extend it to a point, it will come here. Okay. So I will get this image of object here. I'll get the image of an object here. This distance is equal to this distance. Image is always at the same distance where object is. Image is always at the same distance where object is. Size of object, size of object is equal to size of image. Image size and object size are always same. And left side of object appears to be the right side, and right side of objects appear to be a left side. No, what? No, ma'am, we have already read these sheets, ma'am. I know, but it is a little revision. Can we go with the question then? Can we go with the questions? So, only few points are left, okay? So, same size, same distance, lateral inverted means left side, right side, left side. So, these are the things. These are very important things. Very important. Please mark it. Mirror size. 1 minute, please. These are very important points. First, size of mirror is at least half of its own height. Size of mirror required to see full image is at least half of its size. Second, object moves with speed v. Then image also moves with the speed v if mirror is still. If mirror is moving, the speed changes to 2v. Very important. Okay, very important. Now, almost done with the chapter. Oh, periscope is there. In periscope and kaleidoscope, many of you kids have confusion. So let me get these 2 points also clear. We have two more days for questions. Okay. So what is periscope? Periscope is to a tube. A tube connected at 90 degree two times. One tube, second tube, third tube. They are connected at 90 degree. One mirror is here, other mirror just opposite to it at 45 degree. At 45 degree. A ray will go, it will incident back. This ray reflected will incident on second mirror, and then we will get the image. Okay, we can see with our eyes. So periscope, like a tube connected. at 90 degree two times, and we will place two mirrors opposite to each other at an 45 degree. So with this we can see objects placed here, okay, with our eyes here. Any doubt? You have already written this, I know. What are the uses? It helps soldiers, okay, to see crowd from above. We can use this, okay. Now, next thing is kaleidoscope. What is the difference between periscope and kaleidoscope? See, some of you people know this topic, but many of you don't know. So, there is no harm in reading it twice, okay? There is no harm. If you are getting opportunity to read a chapter twice, then it's good for you, right? But I can't allow Gautam, I can't. Yes, Ram, please ask me your doubt. Let me get with the kaleidoscope. We have 2 days. What you will do tomorrow and day after tomorrow? We have 2 days for questions. I'll prepare you a question PPT. We'll cover that. We'll prepare you some quiz also. I'll prepare you some quiz also for tomorrow. Tomorrow we are not going to read this. Just do the quiz for 1 hour. Okay. So let me just complete this kaleidoscope for you. In kaleidoscope, what we have three mirrors. Three mirrors placed at 60 degree. Three mirrors placed at 60 degree. One mirror 60 degree, another mirror, and third mirror also at 60 degree. Angles are 60, okay? 60, 60, 60. Now at one end we will place some bangles, broken bangles or bangles, okay? And we will see it from other, from here. We'll see it from here, and we will see different patterns of bangles, beautiful patterns of bangles. So kaleidoscope is just an arrangement. It is inside a cylindrical box. And on one side broken bangles are there, and one side we have a eyepiece through which we can see, okay? And this is used to see a beautiful patterns of bangles. So you can try it, you can create it at your home also. Okay. Ram, you didn't understood mirrors? See, mirrors are nothing but a polished surface. Mirrors are nothing but a polished surface from where all the incident rays striking gets reflected back at an angle making equal to incident angle. Where the laws of reflections are valid, that laws of reflections are valid on plane mirrors. Okay, mirrors. What is a two-way mirror? Acha, one question. One important question for you. There are two mirrors. Object is here between two mirrors. How many images will be there for this object? How many images will be there? How many images will be there? You want quiz now? Important question. How many? Two wrong, four wrong. How many images will be there? How many images? See, this object image will be here. This object image will be here also. Now for this mirror, this image is working as an object. So one more image. This here, one more image. Now this is working as an object of multiple images. So how many images? Infinite images. Infinite images. Infinite. Infinite images. Okay. Not three, not two, not four. Infinite images. I want the answer for this tomorrow. Tomorrow you guys will explain me on chat why there are infinite images. Yes, every smooth polished mirror surface reflects light. Okay. Now you want one more question? One more question? Okay. Shadow is shortest. In morning, evening or noon? Or same at all the time? Morning, evening, noon or same at all the time? Hey, morning, Arush, Chetan, you guys are wrong. Ram, wrong. Mandapati, wrong. Hey, in water and glass, light travels in different way, Jashwant. Noon. Noon is the correct answer. Noon is the correct answer because light shadow is smallest in noon, that is 12. Okay, in morning and evening shadow sticks. We just studied shadow sticks. So shadows are bigger in morning and evening but shortest in noon. Okay. Okay, mirror moves with 3 meter per second. Mirror moves with 3 meter per second. What is the speed of image? What is the speed of image? Last question, guys. Last question. Last question. Mirror is moving, so image moves with 2v speed. 2v. 2 into 3 is 6 meter per second. 6 meter per second. Okay, 3 is wrong. Okay, now I know my time is up. So we'll meet tomorrow with more questions, more quiz, a little tougher. Okay, so be prepared and we'll see you tomorrow. Okay, guys, bye. See you tomorrow.